All right, everyone, let's get started. Welcome back. It feels like it's been ages since we've been in here, right? What class is this again? What's that? Structural analysis. I'm gonna get that started. Okay, so a couple things. Let's get some housekeeping out of the way. So in the syllabus, I had that we were going to have class on Thursday, and I guess the reason why is because we have our ASCE Virginia's conference this week, and we leave on Thursday, and I figured, well, I'll probably have class and we'll just leave right after. Well, I didn't put two and two together that the conference is at Old Dominion, so we actually have a heck of a drive in store for us. So we're leaving quite early Thursday morning. So if I'm in a van on Interstate 64, I'm not going to be here. So we're not going to have class on Thursday. But in order to keep moving forward, what I'm going to do on Thursday, and I'll probably post it a little early, is I'm going to post the next lecture online. Okay? And let me say this, I'm going to give you a homework today, and that homework's going to be due next Tuesday. Okay? And what I'll say about that homework is this. If you watch that video, the homework will be fairly doable and fairly easy. If you don't watch the video, you're going to have fun with it. Okay? Because, I mean, the homework really does kind of go along with the lecture. I mean, the homework assignment, or specifically it's problem 2. Problem 2 goes along with that second lecture, and if you follow it and sort of step by step, you'll find it's really easy. But if you don't watch the lecture, well, it'll be kind of tough. So I'll pass this out here in a little bit. I have a feeling this morning everybody's shaking the cobwebs off and they're still getting their way here. So that's really all I have in terms of announcements. This room will be open, of course. It's probably a good idea, if you can, to probably come here and work on homework 6. We're going to be using a new software package for the rest of the semester, and it's on these computers in here. So if you can, come here to probably make your homework exercises a little easier. Sound good? Yes.
How easy is it to get MATLAB or
That's a good question, and I'm going to talk about that. Short answer is not easy, but I've got an alternative. Okay, not easy, but I have an alternative. But I'm going to talk about that in the notes here in a second. All right. Sound good? All right. So today we're starting something brand new. We're starting MATLAB, and I'm going to tell you something right now. Go find a junior or a senior in engineering here at Marshall, and just walk up to them and say the word MATLAB, and just look at their face. They're going, no, not MATLAB. No, but in all honesty, it's not bad. I think one of the issues with MATLAB is a lot of times students see it, and it's a lot to take in all at once. So I've decided to redo the way that we teach it a little bit, at least in this section of the course. I think you'll find that all in all it's pretty straightforward. I don't want you, when this is all said and done, to feel intimidated by MATLAB or to feel that it's difficult. In all honesty, it's not. When I was in graduate school, when I did my undergrad degree, I had to take a programming class, but I didn't take MATLAB. Well, when I got to grad school, I found out I had to use MATLAB, and I had never used it before. And it's really not that bad, taken the right way. So hopefully this goes pretty well. One other point I'll mention, if you are a mechanical engineer or an electrical engineer, I would pay particular attention to what we're talking about. You will use MATLAB again. For the civils in the room, there are some specific applications where I think MATLAB will shine very well, but I would be lying to you if I said you're going to use it in every single class from here on out, because that's not going to be the case. But for you mechanicals and electricals, you will use it later on. Okay, so let's go ahead and get started just into it. While I'm talking, if you haven't already done so, I would go onto your computer and open MATLAB just to get it running. If you go into the Start menu, you should see an icon that looks something about like that. So if you could, go ahead and get that, that program open. What happened there? Activation module? Is anybody able, how many people are not able to open MATLAB? Well, okay, we got,
My computer's not working.
oh. I think we've got space, so you might have to try and find another one. That's an interesting, I didn't expect that. Let's see. Okay, so yours is giving you an issue. Oh, no, try just that one. Did that work? Okay. All right, let me know if that gives you an issue. Did that work? Okay. Okay, good. Everybody else able to get it open? Slowly but surely. Yeah, this is. Give it some time if it's giving you an issue. Give it some time. All right, while everybody's in the process of getting this open, I'm going to say a few introductory things about MATLAB. So it's not new. It's been around for a while. It's been around since the late 70s. MATLAB is actually short for Matrix Laboratory. Y'all remember matrix math either from maybe one of your calculus classes, or maybe you did it in high school. Remember like matrix multiplication and all that? I think one of the issues with MATLAB is a lot of times that's where people teach MATLAB starts. They say, here's all this matrix math. And first off, it's probably been a while since you've done matrix math. And then on top of that, you have to learn all the programming syntax and whatnot, so it sort of hits you like a bucket of water. I'm actually not going to talk about matrices for a while. I'm actually just going to talk about the very bare bones basics of how to operate MATLAB. Okay, so I think it's incredibly important right at the beginning to talk about what MATLAB's good for, what it's not good for. Okay, it is good for performing matrix operations. Obviously, it's written for that. It's good for programming or algorithmic-based solutions, and we're actually going to create some of those in here, so you'll kind of understand what's going on with that. Like Excel, it's also good for analyzing large data sets. Also, we're going to talk about this later near the end of the semester, but it will also do symbolic manipulation, which I think those of you who are in calculus are going to fall in love with, because up until now the calculations that we've done have all been numerically based. Well, MATLAB, I can plug in the derivative of x squared, and it will spit out 2x. So it'll actually do symbolic manipulation. And I can see when we get to that, some of you folks in calculus are going to go, oh, this is awesome. So it's what MATLAB is not good for is, I would say, presenting results in a readable form. In other words, engineers generally know how to use MATLAB. Scientists generally know how to use MATLAB. General professionals do not. Okay, so this is really a STEM sort of type of application, and if you're outside the STEM world, it's probably not going to be very understandable to folks outside that community. So that's where MATLAB is not good. It's also usually not very good for what I would call quick calculations. I mean, you can do some quick calculations in the command window, and we're going to do that today. But really, MATLAB's suited for more involved, complex types of calculations, and that's what that's what we're really going to try and focus on. Now, unfortunately, you all can get a student copy of MATLAB, but it comes with a $50 price tag. So there's a couple of options for you. Okay, number one, all the computers here have MATLAB on it, and I assume it's working now for everybody. So you can always come here and work on it. Second, and I have this on my machine, and you all probably want to put it on yours, there's an open source alternative called GNU Octave. Octave looks a little different than MATLAB. It has a little bit of a different interface, but it's free, and it will run all of the scripts that we produce in this class. So you could put Octave on your personal computers and work on your homeworks at home. Another added perk of Octave is that it's Windows friendly and it's Mac friendly. So if you've got an Apple laptop or something, you can use Octave as well. If you go to the website here on the slide, gnu.org/software/Octave, you'll have a page that pulls up, looks something like this. Scroll down, or you can click where it says download, and then if you look here, it says install, and there's a number of different options. For instance, if you have Mac operating system, or if you have Windows, and you can click here, download the latest installer exe file, and then just sort of follow the instructions. It's pretty straightforward. Again, let me click this. The interface looks a little different than what we'll see in MATLAB, but by and large, it will run exactly the same. And for what we do in here, this is more than enough. If you want to work on some of your scripts at home, and you want to use Octave, it'll work just fine. You might find some differences with like colors and whatnot. For instance, when we write code and we place commentary in the code, you can immediately identify commentary in the code because it's green. Commentary will always show up green. Strings will always show up purple. And like for instance, if you notice here, the string is actually, it's like orange or something. It doesn't really matter, it's just a different color. But in the end, the program will run no problem. So I would highly recommend that you all put GNU Octave on your personal machines. It's free, and you can work on all of your homework assignments and whatnot at home. Okay. Sound good? Okay. So if you all have, I hope by now you all have already opened MATLAB. I've got MATLAB open here. Let me pull this up. Okay. One thing I'm going to do on my display, this is something you all don't have to do, but I'm going to go into Preferences, and I'm going to take my font and I'm going to make it a little bigger, say 18. So that way you all can read that, right? Okay. All right. So here's the layout of MATLAB. There's a couple things that are on here that may be on your display, it may not. One of the nice things about MATLAB is a lot of this stuff is very easy to move around. Like this is the workspace, for instance, right here. And I can drag and I can sort of move that like over here, and it'll drag over no problem. So you have the workspace. You have the command window, you have the current folder. We're going to go through each of these in pretty significant detail. So some of these, here, let me blow this up. So some of these might be there, some of them might be not. It's really no big deal. What I think on your interface is most important is that you have your current folder window showing, you have your command window showing, and you have your workspace showing. I'm really not that concerned about whether or not your command history is there. Some of you it might be there, some of you it might not. Students who work on MATLAB, they change the way that the interface looks. So if you don't have the command history, no big deal. But does everybody have the current folder, the command window, and the workspace? Does everybody have that? Okay. And I'm sure everybody has this directory toolbar up top, right? Am I good? Okay. Okay. So I want to just start to play around a little bit with MATLAB and start to explore some of the syntax and some of the functions associated with MATLAB. So first and foremost, one of the, I guess, simplest functions of MATLAB is that it can be a calculator. Okay. So if you notice right here in this main command window, you should see these two brackets, sort of pointing to the right. Does everybody see that? That's your prompt where you can go into the command window and just start doing some very basic calcs. So I can go into my command window. Let's say right here, and I can go in and I can say, all right, let's just do 2 plus 3. So I can do 2 plus 3 and hit enter. And then you'll notice a couple things that happen right off the bat. So number one, it displayed the answer. It said the answer equals 5, right? Everybody see that? And another thing that you'll notice, it displayed a variable here in the workspace. Here it says ANS and it says the value is 5. Okay. One of the ways that MATLAB operates is through the creation of various variables. Okay. So what you'll do is you'll say, if I'm looking at a physics problem, right? So what is it? Velocity equals distance over time. So I might say x equals 10, say t equals 5, and then I'll say v equals x over t. So it's velocity equals distance over time, and it'll calculate that accordingly. And all those variables will show up in the workspace, so it'll help you track what you're doing. But for now, I just want to do some very basic calcs and keep it simple. So first off, I'm I'd say that MATLAB operates very much like Excel in terms of order of operations. So for instance, if I wanted to do, let's say, 7 plus 8 divided by 2, well, that's going to give me a different answer than if I put that in parentheses and say 7 plus 8 divided by 2, right? Because if I go off of order of operations, the first calculation tells me that I do the division first, so 8 over 2 is 4, and then I add 7 and it gives me 11, right? But then the second computation, because I put a parentheses in there, it says, okay, do this addition first, so I get 15, and then divide by 2. So right off the bat on problem 1 on the homework, your first task is just going to be do some basic computations in the command window, and we'll talk about how you turn that in and whatnot later on. Let's see. Okay. So yeah, I mean, just basic, same stuff it was before, you know, parentheses first, then explanation, then multiplication and division, and then addition and subtraction. Just please excuse my dear Aunt Sally. So everybody okay with that? Am I good? Okay. All right, so that's point 1. Okay, point 2. Go away. All right, so while I'm showing you this program, I'm trying to introduce you to some of the basic notation, okay? So let's say you have a really, really long calculation. So I'm just going to start making stuff up. 2 plus 3 raised to the 6 minus 9 divided by 8 plus 14. I mean, I'm just sort of going on, okay? And let's say that this calculation goes on and on and on and on and on, okay? One of the things that you can do to sort of clean up your code or to clean up the way the text displays is you can enter in 3 dots, so 1, 2, 3, and then press enter. Now what? Well, that usually works. If you have a really long, yeah, that usually works. 2 plus 3. Plus, oh, I think I might have to have an operator, and then that's it. Sorry. So after your next operator, put in a dot, 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 and then you can continue on. So I can say 2 plus 7 minus 9 times 3, and so on and so forth. So we probably won't use this very much, but the idea is if you have a really, really long calculation. I think earlier we were talking about Calc 2, right? So if you look at this calculation right here, this calculation is the Taylor series expansion. Y'all Calc 2 folks remember that? So this is the Taylor series expansion of a given function. So you know you've got the value and then minus that value cubed divided by, what was that, 3 factorial plus and then 5 factorial and so on and so forth. So if you keep going on, that calculation is just going to get longer and longer and longer. So after a given operation, if you enter in 3 decimal points, that'll sort of trim things up a little bit. I'll be honest, in the world of engineering, I don't know that I have ever used that calculation very much at all, but it's just there for your benefit. One other point I want to mention. So if you notice, let me scroll up a little bit. Okay. If I look at some of the calculations that I was doing, okay, notice how it was listing the values. You know, okay, it's got 5, and then it's got 11. But any time that I had a decimal value, look how it displayed it. It said, okay, so here's a decimal value, and it said, all right, so 7.5, and then it listed it to 4 decimal places, right? Okay, so this is, I guess, the default display for how MATLAB likes to display given values. Now you can change that display pretty easily through some pretty shortcut commands. So one of the ways that you can change the way that MATLAB will display a given value is by changing the format. So a couple of these formats will change some of the values. Like for instance, the default is format short, so fixed decimal format with 4 decimal points. If I did format long, it would do 15 decimal points. So, like for instance, if I go in and I say, you know, format long, and then I say what's an irrational? Let's do like 3 divided by 7. And see, notice how it's giving me more and more decimal places, so you can sort of play along with that. If you want to get fancy and do something like format bank, what format bank does is it formats all of your output to look like money. So if I do like 160 divided by 7, now it looks like money. You know, it's rounded to the nearest penny, if you will. So, you know, you can play around with that. The default is format short. Okay, so we'll say, you know, 160 divided by 7, and then there you go. Okay, another thing that you can have a little bit of control over is the blank lines that get inserted into the command window. Notice how we got a lot of space here. The reason why we have all of that space is because the typical format, or the default format, is format loose. So it adds blank lines to make the output more readable. But if you've got a lot of different commands going on, maybe you want to clean that up a little bit. So you'll go in and say, how about this? Let's try format compact. Okay. Now if I do a calculation like 2 plus 3, see how it reduced a lot of those blank lines and sort of collapsed everything together. So that should make your life a little easier if you're trying to collapse that down. Now the typical format is, or the default is format loose. So if I do 2 plus 3, then it adds those blank lines in. Okay. Is everybody with me on this so far? Okay. One point I'll mention, you'll definitely want to like try and go along these commands and keep going, or try and, you know, replicate them on your own terminals. I find that the students who actually like do the programming along, they're the ones who do the best. In other words, if you just sort of watch it being done, when it comes to doing your homework, like, okay, wait, what did I do? How do I do that? But if you actually go through and do it, you'll find that it goes a fair amount smoother. Okay. Any questions at all? I mean, this is one of those topics that I really want to make sure that you understand. Okay. And if you've got any questions, please do not hesitate to ask. Very good. Now, one of the other benefits of MATLAB is that for the most part, a lot of the commands or the functions in MATLAB are the exact same as the ones in Excel. There are a few exceptions. Like for instance, the square root. If you type in SQRT of a given number, it will calculate the square root. So if I go to MATLAB and I say, all right, what is the square root of 16? It gives me 4. Okay, so that's pretty simple. Okay. However, there are a few exceptions, and one of the biggest ones, and this took me actually, like when I was first learning MATLAB, you know, I really didn't have an environment like this, so I was just sort of figuring it out on my own. And I remember actually needing to calculate a natural logarithm and going, where the heck is the natural logarithm function? It's not ln like you would think. Actually, the natural logarithm in MATLAB is just log of x. So if you want a base 10 logarithm, it's log 10 of x. And I think that's probably a little new for those of you who have experience with Excel or other, you know, types of, or even just basic math notation. I remember when I was first learning about logarithms, if I just had log of x, that was a base 10 logarithm. But if it was ln, that was a natural log. So that's a little different. I'm just making sure everybody's aware of that. A couple other things. So factorial, you all know factorial. So 5 factorials, 5 times 4 times 3 times 2 times 1, you know, and what have you. Exponential. So if you want e to the x, you know, e to the 2, it would just be exp of 2, right? So if you need the natural base, like what is it, 2.78, what have you, just do exponential of 1, and that'll give you the natural base. Couple other things, your trig functions. So basic notation, sine of x, cosine of x, tangent of x. One of the nice things about MATLAB is it will give you options for whether or not you want to deal with radians or degrees. So one of the easiest ways to handle that is to add a d to the end of all your trig functions. So for instance, if let's go to MATLAB. See, if I do the sine of 30, it gives me a really weird answer. And the reason why is because it thinks that's 30 radians. Okay? But if I do the sine d of 30, well, that answer makes a little more sense, right? Because the sine of 30 degrees is 1/2, right? So by adding a d, all those trig functions will account for degrees. Honestly, with some of the modeling that I personally do, I find it easier to actually convert everything to radians because degrees, at least from a mathematical standpoint, it's an additional conversion that you've got to do. But if you're doing a quick calc, I think that's probably a little easier. Something quick, I'd probably throw the d at the end of the trig function. So just so everybody's aware of the notation, so you got sine, cosine, tangent, cosecant, cotangent. Throwing an a before each of those functions will give you an arc sine or an inverse sine. So remember, if you take the inverse sine, that'll give you the angle, and what have you. And then if you add a h on the end of those, that's where you get your hyperbolic functions. Y'all know what I mean by that, like a hyperbolic sine, hyperbolic cosine, etc. Couple things. All right. So everybody with me so far? Everybody good? Okay. So now let's play around with some basic programming. Now, if you notice, probably your command window is full of a bunch of junk right now, right? Hopefully it is, because filling it up with a bunch of junk as we've been going along with these calcs. Type in the following. Type in CLC and press enter. So that clears your command window. So CLC. So a lot of the scripts that we're going to run later, I usually, like when I run scripts, I like to, at the very first line of the program, I put a CLC in, because if I'm going to run that program over and over and over again, don't put that in, then real quick your command window can be full of a bunch of stuff. So by putting a CLC in at the very beginning, that makes life a little easier. All right, sound good? Okay. Now, what I want to do now is I want to start being a little fancier with my calculation. So I want to define some variables. Okay. So right off the bat, let's do this. Okay. So we're gonna keep it simple. We're gonna do a very basic calc. We're gonna do some area calc. So let's do width equals 2.3. Okay. Now notice I capitalized the W. That's actually kind of important. Now if you press enter, so width equals 2.3, press enter. Okay. A couple things should happen. So if you've done that correctly, you'll see two things. Number one, you'll see that got repeated, like that command got echoed, if you will. Like you said width equals 2.3, and then MATLAB spit it right back out to you. Okay? So that's the first thing you should notice. The second thing you should notice is this. Look at your workspace. Now we have a new variable. It's called width, and we have a value of 2.3. Everybody with me on that? Okay. So one of the things that we need to sort of cover right now is that echo. Okay? So if you did that right, you should have an output that looks something like this. You enter width equals 2.3, and it spits it right back out. Okay? Now, one of the most important pieces of code that we are going to use this entire semester is a semicolon. Okay? This is a semicolon. All right? Now, what I mean by that is this. Okay? Let's do something else. Let's do width. Let's do this again. Width equals 2.3. But before you press enter, put a semicolon after it. So it should say width equals 2.3 and then put a semicolon after it. And then press enter. And notice how it did not spit that output back at you again. Okay? That is going to be incredibly valuable later on when we start writing programs, because if we have a program that's got bunches and bunches of lines of code and we don't use those semicolons, every single line of code that gets executed, it's going to spit something out on the command window, which if you're not using the command window, maybe that's not that big of a deal. But in a lot of our programs, we're actually using the command window to interface with the user. And if there's a bunch of junk getting displayed on the command window, it makes it pretty tough to use. So that semicolon, one of the most useful pieces of code this whole semester. Okay? When in doubt, put a semicolon after a given variable. It'll make your life a lot easier. Okay. All right. Sound good? All right. Now, a couple things about variables. So if you notice, we called that variable width, capital W-I-D-T-H, right? Okay, so a couple things about variable names. Okay, MATLAB is case sensitive. So let me explain what I mean by that. So watch this. See, if I do that, now I've got two different variables, right? Now I've got two different variables, one with a capital W and one with a little w, okay? So make sure that you're being consistent on your case sensitivity, okay? And that's going to be pretty important. I've seen that happen a lot of times when students are writing code. Like they'll define the variable with a capital W, but then later on when they do the calculation, they forget to capitalize the variable, and MATLAB gets upset because it doesn't know what's going on. So make sure you're consistent. A lot of times I just don't use capital letters altogether. I just keep everything lowercase, and it makes it a little easier. But that's just something to keep in mind. All right. Oh. All right. A couple other things. So variables are case sensitive. They can only contain letters, numbers, and an underscore. Okay. So no hashtags, no exclamation points, or anything like that. So some acceptable names for a variable might be speed with all lowercase letters, a capital S, maybe throw a number in there, maybe it's all caps, maybe put an underscore. That's fine. All variables must begin with a letter. Okay, so this would not be an acceptable name for a variable because there's a number in front of it. Okay, and the characters have to be less than 63 characters long, which I don't think you're going to have some variable in an equation that's 63 letters. So I don't think that's really that big of a deal. But yeah. So everybody okay with that? Okay. All right. So now let's go into our command window and let's sort of continue this calc. So we have a capital width of 2.3. Let's do a height, or did I just say height or length? Height. So we'll do height equals 4.1 and do a semicolon. Okay, and it didn't replicate your output, it didn't echo it, but we have the variable stored in there. Everybody good? Okay. Now let's say you're confused. You're like, well, which variable do I use? Do I use the capital W or do I use the little w? Well, one of the ways that you can remove the ambiguity is to just clear out that one. Okay? So if you type in clear space and then put in the lowercase width and press enter, that one goes away. So if you notice now that one variable, it's gone. Sound good? That's not bad, right? Okay. So if we have a height and we have a width, how do we compute the area? Width times height, right? Sound good? Now, for this time, I'm going to leave that semicolon off because I actually want to see what the answer looks like. So let's do area equals width times height. Whoop, it got mad at me. Why did it get mad at me? Lowercase w. Now, watch this. Watch this. I'm lazy. I think that's been a fairly common theme of this semester, is that I don't like, doing the same thing over and over again. Okay, I'm lazy and I don't want to have to type out area equals width times height all over again. Go to your directional pad, the arrow pad, and just go up. In fact, if you go up, see what it's doing? It's cycling through all the stuff that I typed earlier. So I can go to that last entry that I just did, change that to a capital W, and then I'm done. Instead of having to type that code in all over again. You see what I mean? So I just went in, hit up, changed that little w to a big W, press enter, and then look what happened. So So let's be clear on our programming and be clear that we understand what we just did. Okay, we defined a new variable. We called that variable area. Okay, so that showed up here. Now it said that area is width times height. So what it did is it called the value for width, which was 2.3, called the value for height, which is 4.1, and multiplied them. It also echoed my answer. It said area equals 9.43. Why did it do that? We didn't put a semicolon on there, right? This isn't bad, right? Simple stuff. Not too bad, okay? All right. So I want to go into that programming, syntax a little bit in more detail, and I specifically want to talk about the equal sign, okay? Because we just used the equal sign just now, okay? When we did that calc, we said area equals width times height. Well, that equal sign carries with it a connotation on its own. That is an assignment in MATLAB. So when you use the equal sign, this is what MATLAB does. MATLAB says the equal sign on the left side is whatever the variable that I'm assigning to. On the right side is my expression. Okay? So the way that worked is we had area equals width times height. So the first thing that MATLAB did is it actually computed what was on the right side. In this case, 2.3 times 4.1, right? And what was it, 9.43, something like that? And then it took that 9.43 and it assigned that value to whatever was on the left side, in this case, area. Okay? That makes sense? I know that sounds duh. Here's why we need to be clear on that. What happens if I were to do this? Area equals area plus 3. Again, I want you to be clear on what happens from a programming standpoint. The first thing that happens is that MATLAB interprets the code on the right side of the equal marks. So it says, well, area plus 3. Well, area is 9.43. So 9.43 plus 3 is, what, 12.43? And then it takes that value and it assigns it to this. Okay? So I want you to sort of watch your workspace over here. Watch your workspace. So we have area is 9.43, okay? Now, so watch this. I'm going to do area equals area plus 3. Now watch your workspace when I hit enter. It didn't create a new variable. It took area and it added 3 to it, and it took that value and assigned it back to area. Does that make sense? Okay? That's really important. I think a lot of times students see this and they go, well, area equals area plus 3. That equation from a math standpoint doesn't really make a lot of sense. And yeah, I see where you're coming from, but the idea is that that equal sign is acting as an assignment, and we're just assigning a different value to that variable area. Now, that's really important later when we do programming, specifically when we do loops, okay? Because what I might do is I might say I've got 10 values that I'm cycling through, and for each one of those values, I want you to add another 3.5. So it's adding 3.5 to the same quantity over and over again. So there'll be, value equals value plus something, and it'll just keep overriding it, okay? So does that make sense? So I want you to be clear about that overriding aspect, okay? It's all about variables and expressions. Do the expression first, assign that value to the variable, okay? Sound good? All right. Okay. All right. Now, here's another thing. Let's talk about variables. What variable over here on the right have we not mentioned? The answer variable, right? All right, look over here on the right. We have area, we have height, we have width. We defined all those. I created area. I created this. I created that. I didn't create answer. I didn't do that, right? See, watch what happens. If I don't use the equal marks and I just say 2 raised to the 3rd power, MATLAB has to take that quantity and do something with it, okay? It calculates the expression, but it doesn't have anything to assign it to. So it says, you know what? I'm going to take that value and I'm going to put it in ANS, which is the answer variable, okay? If you don't have an assignment, if you don't use an equal marks, MATLAB is automatically going to assign a variable to A and S. It's the standard answer variable, if you will. Okay? So I guess one of the things I should mention is if I go back here, let's look at this. So remember how I said that there are some rules for naming variables, right? They all have to have letters. They all have to have numbers. They all have to have an underscore. Like those, they can't have anything else but letters, numbers, and underscores, right? Another rule I guess I should mention is never name a variable A and S. Don't name it answer because that's a variable that's previously stored in MATLAB. In fact, there are quite a few of them. So the answer variable is a number of is one of a number of variables that are already predefined in MATLAB. I mean, you can name variables whatever you want, but as a measure of good programming, don't name a variable A and S. In fact, you really shouldn't name a variable any of these. So don't name a variable I, okay? Because MATLAB sees I and it thinks square root of -1. See what I mean? So don't call the variable I. So we're actually going to have an example in the next lecture where we calculate a future value of a dollar figure. You know, that's something you'll do in engineering economics. You have a quantity of money now, you put it in a savings account, it accrues so much interest over certain periods, what's the final value? So we're going to be very tempted to call interest I, but we're not going to because I is the imaginary operator. It's the square root of -1. For you electrical engineers, I tends to get mixed up with as current in electrical engineering. So for the imaginary number in electrical engineering, J is the imaginary number. So if you're wondering why J is the imaginary number, well, it's you electrical's fault. So just saying. So a couple other things. Don't call a variable clock because that'll give you the current time. Don't call a variable date because that'll give you the current date. Don't call a variable INF. That's infinity. So if you like 1 divided by 0 or something. Also pi. If you just type in pi, that'll give you the value of pi, 3.14 or what have you. So don't define a variable as pi. Sound good? There are also 17 keywords that you should not use as variable names because those words are specific programming syntax that we will use later. For instance, how many of you, you might not have created one, but how many of you have heard of an if statement? You know, if this statement is true, then this is your output, otherwise this is your output. Very common expression in programming. Well, don't call a variable if. You know, IF, don't call a variable if, okay? There's others. You can't call a variable break. You can't call it end or function or while or else or anything like that. So those are sort of the 17 no-nos. Don't worry, you're not on a test list the 17, you know, no, I'm not doing that. But just be aware that you cannot call a variable any one of those words, okay? Because they're used later for other stuff within MATLAB. Sound good? Okay. All right, so a couple other clear commands, values. So CLC, we use CLC, right? That'll clear your command window, okay? If you type in the word clear, right? So let me make sure everybody's clear on that. No pun intended. So if you do, watch this. So if you do clear, and then I do something like height, but I don't capitalize it, that's actually not a big deal because MATLAB is going to go, it's going to find that variable, and it's going to clear it. If it can't find that variable, it just won't clear anything. But if I actually want to clear height, you know, like with a capital H, you know, I can go use my up arrow. You remember? I can do that, press enter, and then height is gone. Okay? Now if I type in the word clear, and I don't type anything after it, watch your workspace. So I have clear, and I don't have anything, well, it just clears everything. Okay? So sound good? Yes. No. But let me say this. When we start writing scripts, that's not really how it's going to work because we're going to be like hard coding the variables in. Let me put it like this. Today, the deficiency, I guess, with the lecture today is the one thing we're not able to do today is actually save our results. So next time, we'll talk about how to actually save our results by writing a script. Okay? I say next time, but it's actually going to be online. And in that instance, you're going to have a much larger degree of control over what variables get cleared and what ones don't. Does that make sense? Yeah. I tend to be pretty, when I write programs, I tend to be very, very diligent with how I use the clear command. In my research, a lot of the programs that I write are fairly long, like really long. And sometimes I'll write a program to calculate one value. But to calculate that one value, I had to do 30 or 40 different counts. So what I do is at the very end, once I've got that, bless you, once I've got that segment of code working, I'll line by line clear all the variables I don't need, and then I move on. But that's something I take a fair amount of time on to make sure what I'm doing is right. Does that make sense? But yeah, so be very careful about that. Now I'm going to demonstrate what I'm about to do, I'm just going to create some random variables. So we'll say A equals 3. We'll say B equals 49. I'm just making up some stuff. And then Greg equals 2. I just wanted to have a few variables. Okay, let me clear the command window out. So CLC, press enter, and that cleared that out. Okay. I want to talk about these two variables here, who and whose. So, so what I did is I created just three random variables, a little a, a big B, and just Greg, since that's my first name. So let's do who, and press enter, and then it says these are my variables. So it actually lists all the current variables that are in your program at that time. If you do whose, let's see. Okay, so now it gives me a little more detailed information about that data. How big is it? What's its size? The size really doesn't make a lot of sense right now, but if you recall from matrices, matrices are defined by how many rows they have and how many columns they have. It's like a big table of numbers. Well, one value is just one row by one column, so that's why they all say 1 by 1. This is just how much room they're taking up on my hard drive and the type of variable that they are. We'll get into more of that stuff later, but there you go. And if you've had enough of MATLAB and you're ready to go home, just type in quit, and that closes MATLAB. So, of course, you can just close it. Of course, I'm not done, so I'm going to reopen it. Okay. A couple other useful aspects of MATLAB is MATLAB, in my opinion, actually does a fantastic job helping you use MATLAB. Okay, in my opinion, it does a great job with that. If you need help, just type in help with a given function. So if I go into the command window and I say, I don't know how to use the sine function, so help sine. Okay, so it tells me the sine function will tell me the sine of an argument in radians, and it'll tell me the sine of the elements of whatever's inside. It'll even list the reference page for sine. I can click that. Of course, my computer has to run very slowly. But it actually details, this is a very detailed page on how the sine function works. I'm using the sine function because I think that everybody understands it. The function accepts both real values and imaginary values or complex inputs. The sine function returns values on the interval from -1 to +1, right? Because, if you plot the curve, here's the sine function. It always goes from -1 to +1. I think everybody understands that. This is a very useful tool, I think, because I think the sine function is simple, but if I look at, another command, something like fprintf, and I look at this help command, there's a lot more to it, but this is really detailed. I think you're going to find this is very useful later on. Another thing that I have found just in my research and in my time using MATLAB is, watch this. Go to Google and literally first link. Oh, you can go away. But everything that you just saw, MATLAB, I think MATLAB does a fantastic job with that, with making the functions and making the outputs and making the concepts readily available to understand. So so I guess to be formal about it and make sure everybody understands where I'm getting all this. So first off, the first place that you can find help is just literally go into the command window, type help, and then whatever command you're interested in, or variable, or what have you. You can also go on the very top right of your screen. So if you look at the very top right, you should see right here where it says search documentation, way up there on the top right, and you can go in and just type in sign, and then there you go. And you can click that, and it'll bring up that same window that I was talking about. Or you can Google it. Google is always a very nice resource for a lot of this stuff. Okay, and like I said, you can find it online. Does anybody have any questions? Right. So far, does MATLAB seem that hard? It's really not that bad. A lot of people, they see MATLAB and then they think, oh goodness, this is horrible. It's really not. It's actually pretty straightforward. Okay. We are going to do some really cool stuff with MATLAB over the next few weeks. We're going to write programs that's going to get more and more intricate. I have some plans to maybe do some image processing stuff with you all and some symbolic math with you all and just have a blast with it. So my goal is to make MATLAB not scary, okay? Because it really shouldn't be. It's pretty straightforward stuff. In fact, the programming language itself was written to be simple. It wasn't written to be complicated. It was written so that anybody could just pick it up and figure it out. Anybody with basic programming experience should be able to use it, no problem. Sound good? Okay, so I'm going to pass this out and give you all some time today to work on at least problem 1. So here's this. And I'll make sure everybody's clear on the housekeeping for what comes next. Okay, so let me show you all something before you all get too heavily started into this homework. If you go to the Start menu, do you all have a little icon that looks like a little scissors right there? You all have that? Okay, this is called Snipping Tool, and if I bring up Snipping Tool, you should have a little window that pops up like this, and all you have to do is click the New command, and the screen should suddenly get a little fuzzy, and you can just sort of drag over a given region, and then now you've taken a screen clipping of that region. And you can copy and paste that image, so I can hit, edit and copy, then maybe open up a Word document once it decides to open. Come on. And then I can just paste that image in. So there's the image. Does everybody see that? So again, just go to Snipping Tool, and then just hit New. And you can drag over something and just copy and paste that image. Everybody okay with that? here's the reason why I bring that up. So here's your homework assignment. Okay, and problem 1, you just need to do the following calculations in the command window. But because you haven't learned yet how to save them, because that's coming next time, what I'm going to do is this: just do each one of these calculations, and then, like, you know, like to give you a for instance, like go into the command window. Like, let's say you've got 2 plus 3. So do 2 plus 3, and then just screen clip that. So hit new, just copy that, edit copy, then edit paste. So that tells me that you did it, you know. So just do that for each one of those calculations and save it on your network drive. That's it. That's your problem 1. Now problem 2, I do want to at least show you a couple things on problem 2 so that you understand. So problem 2 is much more involved. So let me explain what's going on problem 2. Problem 2 is going to involve actually writing a program, writing a script. And we haven't done that yet. We're going to do that in the online lecture next time. But here's the essentially the fundamental equation that you're going to use. So what you're going to do is this. You're going to write a program to calculate this quantity. Essentially what this is the bearing capacity of a foundation. So you all know if you build, you know, like a house or a building or something, you have to have some structure in the ground to keep it up, and that structure is a foundation. And one of the most fundamental types of foundations is a shallow foundation. And to compute how much that foundation can hold up, we use the following equation. There's a lot of factors that go into it, and when you civil engineers take geotechnical engineering, you'll learn all about it. But for now, I just want to make sure that you can use the program. So you're going to define a bunch of variables inside MATLAB. And I've even told you, like, this value here, like, just use y as the variable names. I've told you what to name all the variables. MATLAB doesn't interpret units, so you're just going to go in and type the values. Let me be clear, though, just so everybody's clear. We have not yet covered script, so you're not really going to be able to do much with this problem 2 today. You'll be able to definitely work on it once I get that video posted. My plan is to get that video posted for the online lecture sometime tomorrow, and it'll probably be on the order of like 30 minutes. And if you watch that, this program won't take you more than 15, 20 minutes to make. It's pretty simple. Okay? I'm basically, in all honesty, I'm kind of telling you step by step what all to do on each line. Sound good? So you're going to have some basic variables to compute. You're going to write some script where you ask the user to input certain values, and then you'll do some computations and close it with an if-then statement. The only other thing that's worth mentioning is I'm going to have you write this program, and then I'm going to have you use it with some, you know, test values. This B equals 4 feet, DF equals 3 feet, and so on. And then you're going to use these values and tell me whether or not the foundation is safe or not. Is it adequate to withstand the loads? And you're going to tell me that by typing it at the end of your Word document. So, you know, your Word document should contain all the pictures and then some text at the very end. Sound good? And that's all I got. I will leave you all to working on your computations in engineering computations.